Namaskar my dear friends. Let's talk about diode circuit in LTSpice. So we'll have lot of diode circuitry, whether it is forward biased or reverse biased, or maybe like we have some voltage divider type something. So we'll try to have various kinds of diode circuitry and we'll see the response in LTSpice. So let's open LTSpice. As we can see, we have a new circuit, let us say, and we'll just put a voltage source, let's say V as voltage source. Then we'll put one ground terminal. We'll put diode, so we can press D for diode, so this will be D. Now if you want to rotate it, we can put it R, control R will be for rotation. And let us put one resistor, so by pressing R you can get one resistor. Now let's just keep it wired up, so by wiring we can put W, that will make us wire. Otherwise you can press this icon to wire it up. Okay, so we'll press W to get a wire and we can continue wiring. Okay, now the beauty of this particular LTSpice is you don't have to specify the diode part number. If you do not keep anything, then it will take up normal diode which is of 0.7 volt drop. Okay, now what I'll do is I'll just have a voltage source. Let me keep a pulse source, so we'll have like a 0 volt initial, final volt will keep 5 volt. Okay, so 0 will be off time and 5 will be on time. Let us assume delay is 0. Then let's talk about rise time as 1 microsecond, fall time also 1 microsecond, on time will keep 10 millisecond, off time also will keep 10 millisecond, so that will become T period as 20 millisecond. Okay, so on plus off put together is time period. So this is how you are going to define your pulse voltage source. Okay, now let us keep one resistor value. So what do? We can keep, let us say, 5 kilo ohm. So 5 volt by 5 kilo ohm, so approximately it will be 1 ampere, like 1 milliampere current will be flowing, right? Now since there is a drop across the diode, so there will be little bit less than 1 milliampere current in across the resistor. Now if we run this particular circuit, it is asking for transient analysis and it is asking for a stop time. So we can run for 100 millisecond, since we have 20 millisecond as one period. So let us talk about, let's say, 5 periods we want or 5 pulses we want. We can run it for 100 millisecond. The time to start saving data, we can start from 0 itself, like beginning time itself. So this is how our transient analysis has been set up. Now if we see on this particular node, if you want, we can, for better visibility, we can name these nets, right? So what we can do is we can put N for naming the net. So this is my V in, I'll put V in on this particular place, and this will be my V out. So what I'll do is I'll just right click on this net and name it V out. Okay, that's all. So let's rerun it. Now once we run it, we can have a voltage probe here. Once we voltage probe, you can see we have 0 volt to 5 volt. Okay, so 0 to 5 is the input. You can see V in as 0 to 5. If you want, you can rescale these scales. So let us say I want it to be like 1 volt sticks. So 1 volt will be there, 0, 1, 2, 3, 4, 5. Okay, and it has run for 100 millisecond. Now let us run at output. So what will happen? Whenever it is high, then diode will be working, and whenever this will be low, like input will be low, diode will not be working, right? So you can see the output is following the input voltage just by a reduction of 0.75 volt. Okay, so you can see 0, then 0.75 volt has been reduced, you can see here. If you want to have a cursor on this, you can go here on V out and press click, then cursor will appear, and you can see this cursor is there, which you can see what is the cursor value. The vertical value you can see 4.34, or it almost like 0.7 volt drop is there. Okay, good. So this was all about the diode circuit. If you want to have what is the current across the R1 resistor, you can press this cursor across the component and you will have a current probe. So current probe is there, IR1, which is red color, and that's how you are going to get your current across the resistor. Okay. Let us quickly move one more circuit. I will just copy this particular circuit, and what I will do is I will take a new circuit and make the diode as reversed one. Okay, so let us move this diode and let's say reverse it. Okay, now what will happen? Everything is same. I am going to run this particular circuit, so whenever the voltage is low, then only it will be on, and whenever voltage is high, it will be off. So like that the circuit will be there, right? So this is my circuit. You can see this is my input voltage, which is 0 to 5. What will be the output voltage? So output voltage will be always 0. Why? Because there is no negative voltage, right? So what we can do is, in this pulse source we can have beginning, let us say -5, and on will be 5. So what will happen? As you can see, my voltage is from -5 to 5. I'll just show you input voltage only. So -5 to 5. Okay, so whenever this cathode voltage is less than anode voltage, that time it will be on, right? So what will happen? My V output, you can see my V output is going low at, like whenever this is lower side, right? Because that time the diode will be in on condition. Okay, so since this particular voltage is low, that is -5, it is working, and you can see current across this will be negative at that time. So IR1 is almost, how much it is? Leakage current is there. You can see it is leakage current. Okay, so this is all about diode circuitry. What we can do is we can take another circuit. Let us remove this and take another circuit. Let's do something new. What we can do is, let me just put one resistor here and one diode here. Okay, and I want to know what is the voltage level at the node. Okay, and what I'll do is I'll just put at this place, let's say this. Okay, now what we'll do quickly is we are going to connect this particular circuit, and we are going to identify what is the voltage at the particular place between the resistor and the diode, and you have to find it out manually as well as from this circuit. So let us connect this. Okay, the values for all these things is, let's say this is -3 volt, and since we know the diode voltage is basically, I'll just cut it again, make it proper connection, or sorry, okay, it is correct. So let's say the resistance value, I'll just put it 1k, and this voltage, since the diode voltage is generally considered as how much? 0.7 volt, so we can put it here 3.7, so that it will be switched on. Okay, now what would be the voltage at this particular point, which is at V out? Okay, so V out I am going to consider at this particular node. Okay, or what you can do is you can put a wire here, and then you put this V out there. So put M and move it at this location. Okay, so let's run it and see what is the stop time. We'll just put it as 10 millisecond and start with 0. Okay, so as you can see, we have input voltage which is 3.3 volt. We have this voltage level, you can see this is -3 volt. So this is -3 volt, little bit bluish color. Okay, -3 volt. Now what should be the V out? So V out, you can see it is, since I am not able to see here, I'll just make it little bit this side. Let's say -4 volt, and this one let us say 5 volt I'll keep, and this one let us say 0.4 volt I'll have a ticks. Okay, so this red color is coming at this place. If you want, we can have a cursor on this, and you can see the cursor on that particular line is basically, you can see this is the line. So since that is there, it is showing you minus 2.29 volt or minus 3 volt it will be there if the diode will be ideal. So this kind of questions is always there in your examinations and you will be able to identify very quickly. So if this is an ideal diode, 0.7 will be enhanced, and this is how you will be getting minus 2 plus 0.7, that is going to be minus 3 volt. Okay, and why will happen that one? Because this is going to be forward biased. Let's take another circuit and then we will finish up our discussion with diode circuitry. So what we'll do is we'll quickly make one more circuit. Let's put one resistor, one more resistor here, one voltage source here, and one diode at this location. Okay, now based on the voltage drop across R2, diode may be working and may not be working. So if the voltage drop across R2 is more than 0.7 volt, diode will be start working, and if it is less than 0.7, diode will not be working, right? So that's the understanding we should have. So this is very good circuit for analysis purpose, and generally these are actually very much important for a lot of circuit analysis related to diode circuits. So as you know, the voltage drop across R2, let us say we are going to keep this as 2 kilo ohm, and let's say this one we are going to keep it as 6 kilo ohm. Okay, and the voltage across this voltage is, let us say, 2 volt. Okay, so what will be the voltage at this particular point, which is, let us say, I am going to name it as V out. So this will be my V out point, and this will be, let us say, my V in point, V in. That's it. So since we have decided everything, what is the voltage at this particular V out point? So you can see 2 multiplied by 6 divided by 8. So 6 duna 12 divided by 8, that is close to 1.5 volt or something. Sorry, it will be 0.5 volt, right? So let me just run it. 10 millisecond, and let us say start from beginning itself to save the datas. Now as you know, the input voltage is 2 volt. What is the output voltage? Output voltage you can see 1.5 volt, right? Now let me just remove the diode, and see what is my output voltage. So output voltage is actually 1.5 volt. Now as you can see, 1.5 volt is coming because it is 3 times, right? So you can see since the output voltage is 1.5 volt, the voltage across this diode, this resistor, is actually 0.5 volt, right? Now let's put the diode. So the thing is, this particular diode would not be on, so the current across this diode will be very, very less. So what is the current across this resistor we'll see, and this diode we'll see. Okay, so you can see current across this diode is just 0.2 microamperes. Okay, now let's make this diode on. So to make the diode on, the voltage across this will be how much? So how to find out voltage across R2? That is little tough, right? So you can see V output is coming as 1.5 and V input is 2 volt. So you are able to find out 2 minus 0.5. That's how you are finding the voltage across R2. Let us say we want to find out voltage across R2 only. Then what we can do is press this button and then control and then put here. Okay, what will happen? This one, or you can do one thing, like it will come at V input minus V output. So for that, press like this and then hold it and put it like this. So you are going to get V of input comma output. So input minus output, that is coming up as 0.5 volt red color. How to do that? Let me just delete all of them. This is my output voltage, V output, but voltage across this R2 is V input minus V output. So what we have to do is press control, keep it here, this one, and hold it. Okay, and then come here. So it is coming a image, right? And then take it. So you can see the red color is coming as V in minus V out. Okay, so you can see this is 5 volt. Now let's increase this particular voltage to